Welcome back to the terminal. Today, we're tackling one of the most important shifts in modern networking. This is Module 1, Lesson 6, IPv6 Basics, where we'll unpack what 128 bits really means and why the internet needed to move beyond IPv4. Think of this as the moment we stop patching an old system and start exploring the one built to replace it. So why bother with IPv6 in the first place? IPv4 gave us roughly 4.3 billion addresses, and between phones, laptops, servers, and every smart device imaginable, we burned through them. IPv6 jumps from 32 bits to 128, unlocking around 340 undecillion addresses, enough that every device can have its own public IP, no NAT required. And notice the format shift too. 4 decimal octets become 8 hexadecimal groups, like 2001 DB801. It's not just longer, it's a cleaner redesign. Let's break that format down. An IPv6 address is 128 bits, split into 8 groups of 16 bits each. We call those groups hextets, written in hexadecimal and separated by colons. The first 4 hextets typically identify the network, and the last 4 identify the specific interface on that network. That split usually lands right at the halfway point, which is why a /64 prefix is the standard subnet size you'll see almost everywhere in IPv6. Now, writing out all 32 hex digits every time would be painful, so IPv6 gives us 2 shortening rules. First, inside any group, you can drop the leading zeros, so 0db8 becomes just db8. Second, you can collapse one run of all 0 groups into a double colon. Here's the catch, and it's a favorite exam trick. You can only use that double colon once per address. Use it twice, and the address becomes ambiguous. With the format down, let's look at the address types you'll actually meet in the wild. Global unicast, starting with 2000, or 3, is your public Internet Routable address, the IPv6 equivalent of a public IPv4. Link local in the FE8010 range is auto-configured on every interface and used only on the local link. Unique local under FC007 fills the role of private addressing like RFC 1918 did for IPv4. And multicast FF008 handles one-to-many traffic, because here's the key thing to remember. IPv6 has no broadcast at all. Multicast does that job. And that wraps up our IPv6 fundamentals. Next up in Lesson 7, we're shifting gears into wireless networking fundamentals, how Wi-Fi actually works, the standards behind it, and how it fits into a CCNA level network. If this lesson helped things click, hit like, subscribe, and turn on notifications so you don't miss what's next. The full course is free on YouTube and available at dargslan.com. See you in the next one.